So we know what the price elasticity of demand equation is. It's the percentage change in quantity demanded divided by the percentage change in price. In the example with tacos that I provided to you, I gave you those percentages. So the price of tacos changed by 5%, while the sales fell by 10%. And you just go ahead and insert those numbers or substitute those numbers into that equation, and you're good to go in order to find the price elasticity of demand. However, things aren't going to be as simple all the time. Things can get a little bit complex because we are also concerned about having an initial starting point and seeing where we end up. So we have an initial price and quantity, we have an ending price and quantity, and we want to see what the elasticity is going to be when we go from A to B. And that's exactly where the midpoint method is going to come into play. And when we go ahead and do the price elasticity of demand, it's essentially going to be some type of percentage change. And you might be wondering to yourself, why don't we just go ahead and use the base method? And the base method is just essentially a percentage change. You might have known it's going to be the final value minus the initial value divided by the initial value. Why can't we use that? And the reason why we can't use the base sort of method in order to calculate out the price elasticity of demand is because we will get different percentages depending on if we're going from point A to point B or from point B to point A. That will change under the base method. So in order to get around this issue, we go ahead and use the midpoint method, which allows us to get the price elasticity of demand, and it doesn't matter where we're going or where we're coming from. If we go from point A to point B, if we go from point B to point A, if we use the midpoint method, we will always get the same percentage. So let's go ahead and see the midpoint method in action and see exactly how we formulate it. So here, this is going to be the big equation for this particular chapter, the midpoint formula. And the midpoint formula is exactly what we use for all the elasticities that we're going to be seeing, not only in this video, but also in the next sections as well, where we talk about other elasticities. So here for the price elasticity demand, it's ED, and we're going to open our elasticity equation up with a few components. We have Q1 minus Q0 divided by Q0 plus Q1, and we want to divide that by 2. So we'll put a few things in brackets right here. So here we have Q1 minus Q0 divided by Q0 plus Q1, and divide that portion, this sum, by 2, and then we'll get essentially the percentage change in quantity demanded. So this is our percentage change in QD. So essentially this big portion in the brackets is our numerator. We have an initial quantity value, we have an ending quantity value. So Q0, Q1, where we're starting off, where we're going. Once we have this, we need to build up the denominator. So here, we take this entire big value right here, divide it by the denominator, and that's where the percentage change in price is going to come into play. So we have P1 minus P0 divided by P0 plus P1 divided by 2, and use the same bracket notation right here. And once we have this, this is going to be our denominator, and this is the percentage change in price. So here we still have the same equation for the price elasticity of demand. It's a percentage change in quantity demanded divided by the percentage change in price. But now we're opening these sort of things up a little bit. Here we have initial values for prices. We have ending values for prices and quantity. So now we want to go ahead and see what the price elasticity of demand is with this midpoint formula. So this is something that we're going to be seeing throughout the rest of this chapter. So get a lot of practice setting this midpoint formula up. And suppose that I tell you that I want to calculate the price elasticity of demand from A to B given this particular graph right here. So here, suppose I give you a demand curve, call it D right here, and we want to go from point A to point B. So point A, point B, and we have some type of price quantity combinations. Suppose at point A, we have a price equal to 2 and a quantity equal to 300. And at point B, we have a price equal to 1 and a quantity equal to 500. So based on this, the question that we want to go ahead and ask is calculate the price elasticity of demand from A to B. And in this case, it really doesn't matter if we go from A to B or from B to A. We will get the same exact percentage because we are using the midpoint formula. So easiest way for us to start us off is to go ahead and say, hey, what's our starting point, what's our ending point, and label these type of things. So we are starting off at point A in this instance. So at point A, this is going to be our Q0 right here. So 300 is our Q0. while 2 is going to be our P0. So here, anytime we start off, we immediately label it so we know these are starting points. When we go to point B, this is going to be our ending point, so we know that 500 is going to be our Q1, and $1 is going to be our P1. And once we successfully label these prices and quantities, we can go ahead and insert them into our equation that we have right here. So let's go ahead and take a look at the percentage change in quantity demanded first. So what is our Q1? What is our Q0? It's going to be 500 minus 300. And then we want to go ahead and divide it by the sum of these divided by 2. So 300 plus 500 and divide that by 2. So here, keep the brackets. Orders of operation are going to matter very greatly right here. So make sure you know how to use your calculator in order to solve these things out. So here, we've successfully set up our percentage change in quantity demanded. Next, we want to build up the percentage change in price. So we have P0, we have P1. So P1 is going to be, so based on the equation that we have right here, P1 minus P0. P1 is going to be 1. We subtract out 2, which is P0, divided by the sum of both of these. So 2 plus 1 divided by 2. Keep the brackets consistent. And then there you go. That is our percentage change in price. And you notice that because once again, we are dealing with a price elasticity demand, at least one of these values is going to be return a negative number. So here, it's either going to be on the numerator or it's going to be in the denominator. Here, we notice that, hey, 1 minus 2, that's going to be a negative number. So it's going to be in the denominator in this case. So insert this into your calculators, or if you want to go ahead and do it long ways, you can do it on pen and paper as well. You just want to go ahead and simplify as much as you can. So here, we get a positive 200 over 400. That is going to be still the percentage change in quantity demanded. And then we want to go ahead and divide it by, keep on simplifying, negative 1 over 1.5. So here, just simplifying, we have a positive in our numerator, we have a negative in the denominator, and then just keep on simplifying. So here, 200 divided by 400 is 1/2. We divide this by negative 2/3. So here, if you do that into your calculator, 1 divided by 1.5 will give you negative 2/3. And then the final step is to go ahead and keep on simplifying as much as you can until you get one singular number. If you want to do the long way, remember that when you divide fractions, you just go ahead and flip the denominator over the reciprocal and multiply, or just go ahead and insert it into your calculator. That's perfectly fine if you don't want to go through all those steps. Here, when you go ahead and get the simplified number, you're going to return a negative 0.75. However, because this is the price elasticity of demand, what is always our final step? Our final step is to always go ahead and take the absolute value. So here, absolute value, negative 0.75. This will return us a value of 0.75. So essentially the price elasticity of demand as we go from point A to point B is equal to 0.75. So a 1% increase in the prices is going to cause a 0.75 decrease in quantity demanded and vice versa. So with all of this, what type of good are we taking a look at? Is it considered elastic, inelastic, or unitary elastic? Because it is a fraction, it is less than 1, this is considered to be an elastic good. So anything less than 1 is a decimal, we get an inelastic good, an absolute value. So I would encourage you to go ahead, get as much practice as you can with this midpoint formula right here. We'll do it quite often. And go ahead and go find the price elasticity of demand as we go from B to A instead. As you go from B to A, you're going to notice that the negative is actually going to show up in the numerator this time. But essentially the same steps are going to apply the same methodology, and it will return you the same answer right here. So anytime we use the midpoint formula, you'll always get the same percentage. You'll always get the same answer as you go from A to B or from B to A. So we'll go ahead and do a few more examples with this in the next few videos with the next elasticities that we need to go ahead and talk about. I'll see you guys there.